Good morning, students. So this is the tutorial explanation for the linear motion. It's the first tutorial for the chapter 2. So this is the recordings done due to the class we missed yesterday. Okay, so I'll try to give some basic explanations so that everyone, okay, so from all range of ability students will be able to understand. So first we go to the question 1. If my voice is, I hope my voice is fine. Okay, so clear. So first, define acceleration and state whether it's a scalar quantity. So I think this is more of a qualitative explanation. So we understand acceleration. When you say acceleration, you can find this in your notes. So acceleration, we understand it's the rate of change in the velocity. Okay, it is found in your notes. Rate of change in velocity. I'm explaining because some students probably, okay, so they are still fresh, okay, so to the physics, they have not done physics, okay, so I know from what I have spoke to some of you all. So formula wise, okay, so we can put it as the final velocity minus the initial velocity divided by the time. V is the symbol that is used to represent the final velocity. U is the symbol used to represent the initial velocity. Then about scalar or vector. So obviously we know acceleration is a vector because it has magnitude and direction. So because it has magnitude and direction, it comes under the category of vector quantity. Sorry. Okay, more next. So nothing much further to spend on the question 1. So we move on to the question 2. A car. Okay, so before we go to the question 2, I always like to advise, okay, so when you are doing the question, as you read the question, try to accumulate informations about that question. Anything you can highlight or you can actually sketch it out, okay, draw a diagram to represent the story, okay, so the informations that is given in the question. So that will make you, okay, to able to see oversee the whole question and easier to understand. Okay, so come, let's move on to the question number 2. A car initially traveling at 16.7 meter per second accelerates at a constant rate of 2 meter per second per second. So you can write the formula in the symbol. So a car initially traveling. So this is the initial speed. Accelerates a constant rate. That's an acceleration. How much time? Okay, so what we want to find is the time. So I can put a question mark. So I know I want to find the time required for the car to reach to a speed of 25.0 meter per second, which is the final speed. So you try to recall the formula. So before you start with the tutorial, you can write the equations that you need to you will commonly use for the question or for this particular tutorial. So for example, the first one, when we define acceleration, the formula is V equals to U plus AT. So we have V squared equals to U squared plus 2AS as equals to UT plus half AT squared. And also you have another formula as equals to the U plus V initial speed plus final speed divided by 2. Doesn't matter whether it's initial plus final or final plus initial is the same. Then you multiply by the time. So this is basically relates to the average distance traveled by the object. So that's why you don't find the acceleration in the formula. So, but this is also applicable, you can use. So come to this question, you want to find the time. I can see The second formula, there is no time involved, so it is out. So I put 1, 2, 3, and 4. So second formula is out. So it's either between the first one and the third one. So whichever we have enough information. I know the final speed, I know the initial speed, I know what is the acceleration. So here, clearly I can see the first equation can be used. So therefore, now I write V equals to U plus AT. So the final speed is 25.0 plus initial speed is 16.7. So equal plus the acceleration is 2 multiplied by the time. So therefore, your time will be basically equivalent to 25.0 minus 16.7 divided by 2. Okay, so 2.0 lah, to be more specific. So you get your answer. You should get about 4.2, suppose. Okay, you can work it out. Okay, so from what I have, okay, so it is 4.2 second. You round it up to 2 significant figure because the raw data that is given is also into 2 significant figure. Okay. Hold on now. So let's go to question number 3. A chart starts from rest and accelerated uniformly at 4 meters per second. So this is an acceleration. It starts from rest, meaning my initial speed is 0 for a time of 5 seconds. It next maintains the velocity it has reached for 10 seconds. Okay. Then it slows down a steady rate at 2 meters per second. This is basically the deceleration for 4 seconds. So what is the final speed of the chart? Okay, if you look at this question, there is a lot of part. Okay, so a story, continuation part, different part. So therefore, once you read through, you may not able to picture the whole thing. Okay, so as one. So best way is to tackle this question, sketch a graph. So just say if I were to sketch a graph to show how the velocity, okay, so the velocity varies with the time. So I can start lah now. So when from rest, it accelerates uniformly at 4 meters per second for 5 seconds. Okay, so what I'll do, I'll just draw a straight line. Okay, so for 5 seconds, this is 5. Because it is already mentioned, accelerated uniformly. Okay, so you're supposed to get the acceleration as 4. So if I'm getting acceleration as 4, here is 0. So here I should have a value. Okay, so which I don't know. Can put this as V. Okay, so the acceleration is already given as 4. So therefore, if I use the formula, 4 equals to the final speed, I don't know, V minus 0 divided by the time taken, 5. So therefore, my velocity here, I can just put V1 first lah. Easier. So my V1 equals to 20.0 meter per second. Okay, or 20 meter per second. So I can put it now, 20. Done. First story. it next maintains the velocity it has reached for 10 seconds. So the velocity I reached, which is 20 meter per second, it maintains for 10 seconds. So maintains for 10 seconds. So if this is 5, then this has to be 15. Okay, done. After that, then it slows down a steady rate of 2 meter per second for 4 seconds. So for 4 seconds, which is going to be 19. Okay, so for 4 seconds, so then it eventually is going to reach 19. Okay, so what is the final speed? So the final speed, so here it is, this is the final speed. So I put this as V2. This is my V. It takes 4 seconds here. Okay, so I can find the, you want to find the final speed. Okay, so you put V2 question mark. So I know I want to find the final speed. But before I can find the final speed, I need to find the acceleration first, the deceleration, because it's slowing down. So again, okay, so I can say this is the part 1. Okay, so this is, I put this as part 1. Then I take this as part. I can take it as part, because there is also a part, this part here. So I just take this as part 2. Okay, so we know that from this part here, the deceleration, so we know it is minus 2.0 equals to the final speed is V2 minus the initial speed, which is 20, divided by the time taken is 4 seconds. So with this, I can find my V2. So 4 is so 8, so 12. So I get 12 meter per second. So that is my final answer. Okay. So that's how you solve. So the final, so what is the final speed of the chart? Okay, so it is 12 meter per second. Okay. Question number 4. A rock is dropped from a vertical cliff. The rock takes 7.77 seconds to reach the ground below the cliff. So what is the height of the cliff? Okay, so the rock is dropped from a vertical cliff. Okay, so I can just put a cliff here. The rock takes 7.7 seconds. So I can just put this as the time taken 7.77 seconds to reach the ground below. So we know additional thing, acceleration must be equivalent to negative g. So what is the height is coming down? The object is drop from a vertical height, then we are expecting the initial speed should be 0, even though the question does not mention. So because they say it is dropped from a vertical cliff, it is not been thrown or launched. When it is stated thrown or launched, means you are applying a initial force to move it. But when you drop it, okay, or release, meaning you are just releasing it. Okay, so there is no force because it is dropping from a higher to a lower. There is a loss in the gravitational potential energy. So automatically when you release, the object will start to move. Okay, so that's why we don't really need the force over here for the object to move downward. So we want to find the maximum height. Okay, So which formula I can use? So you can just look at this formula. So we want the height. So obviously equation 2 and equation 3. But equation 2, I don't know what is the final speed. Okay, acceleration we know. Initial speed we know. The final speed we know. So cannot. The distance, yes. The distance in the formula, we can find the distance. But we don't know what is the final speed. So there is information not enough to solve the problem with this way. So then look for the next one, which has the distance. So is S equals to ut plus half at squared. The fourth one also cannot because we don't know final speed. So use the third one. Okay, so I write the formula as y equals to uyt minus half gt squared. So I did mention to you, when you are talking about vertical, immediately you can transform the equation to refer to the vertical. So the vertical displacement, okay, h. So I put minus h. Okay. So then my ui is 0. So the whole thing will be 0 lah. 0 times the time minus half half 9.81 t squared, which is 7.77 squared. So you work out your answer. So you will get a negative. I mean, even if you didn't put a negative here, also fine. Just say if you didn't put a negative here, it's okay. So your answer will end up giving you a negative. That shows the displacement is downward displacement. So you kind of get 293.13 meter. So therefore, you can finally conclude this. Sorry, 96, sorry, 96. So you can round it up this to 3SF. Okay, so you can give it as the height is equivalent to 296 meter. So it's quite straightforward solving the problem. Only thing is you must ensure which formula to use, and are you substituting the informations into the formula correctly. Let's go to question number 5. A ball is thrown straight up with a speed of 33 meter per second. So the ball is thrown vertically up. Okay, and then we know that the initial speed is equivalent to 33 meter per second. How long does it take for the ball to reach the maximum height? It is very similar to the one we discussed in the class. Okay, so no, what is the formula? So before that, we need to understand when the object reaches to the maximum height, the final vertical speed will be equivalent to 0. Throughout the motion, acceleration is taken as negative g. So that's it. So how long the ball will take to reach to the maximum height? Few ways you can approach, but its easier way is to use the formula A as y equals to uyt minus half gt squared. So when the object returns back to the hand, take for the ball to reach the maximum height. Oh, okay. So this is to reach the maximum height. Okay, we don't use this formula because this one is the time taken for the whole flight. So erase all this. So the other formula I can actually use is the V equals to U. So basically Vy equals to Uy minus Gt. So the initial speed when it launched is 33. The final speed when it reaches the maximum height is 0. So here you have 33 and minus 9.81 t. So from here you can find your t. So what is your t? 33 divided by 9.81. Okay, you should get 3.4 seconds. Okay, so that is for A. So what about for B? What is the maximum height reached by the ball? So you want to find the maximum height reached by the ball. Obviously, I need to use the formula Vy squared equals to Uy squared minus 2G Sy. Okay. So therefore, the final vertical speed is 0. Initial vertical speed is 33 squared minus 2 times 9.81. And Sy is basically the maximum height reached by the object. So, you can use this formula. So you have basically 33 squared. Okay, that's my calculator. Just check. So 33 squared divided by 2 times 9.81. Oops. I get a systematic error. 55 meter. Okay, correct. 55.5 or something. Okay. So this actually gives us h equals to 55.5 meter. But actually, you can also use by another formula. So this is using V squared. So I can also use the formula or Sy equals to Uyt minus half GT squared. And so you know your initial speed 33 multiplied by the time that you already found in the earlier part. Okay, 3.4. Then half GT squared. So 9.81 times half T squared. And your Sy. Okay, so your time you already calculated. Okay, so you can substitute inside. So yes, in that case, you can find your S. This one also can. So either way, you can approach, provided that you know what is the information that you have to solve the problem. Okay, and formula which to use. Okay, last question and the last part, C. So what is the speed after 5 seconds? So if you want to find the speed after 5 seconds, so we can just use Vy equals to Uy minus GT. We know the initial speed is 33, is moving upward. Okay. So after 5 seconds, hold on. Okay, so back to this. So we know the initial speed is 33 minus 9.81, then multiply by the time 5 seconds. Because we want to find the speed after 5 seconds. So 5. So therefore, when you work out, you get 16 point something. Okay. So yeah. So you have 16. Okay. So in fact, you get minus 16. So you get minus 16.05. That shows the object is already like on the way coming down. Okay. So but if you just say magnitude only, okay, so then you can just take it as 16.1 meter per second. So that is basically indicating it is coming downward. Okay, despite the negative sign. So, but you can ignore the negative sign in the final answer, but probably you can just write down it is on the way coming down. Okay, so part one of the video ends here.